Assalamualaikum warahmatullahi wabarakatuh. My name is Nurul Isati binti Zulkifli. I'm from Electronic Network Design. Today I will explain LAB1 for Part 1 Basic Equipment Component. For the task 1, try the LED as digital monitor. Use the power supply as your input. Start at 0 volt, which is 0 volt. Slowly increase the output voltage to 5 volt. Then we must know what level for voltage to LED turn on or off. Okay, so first of all, we must open the multisim. And we must find the equipment, this is a DC power, resistor, LED and ground. Okay, to find the DC power, we must search select a component, then we just type at component DC power. Okay, so for resistor, we just type here resistor. For the LED, we just type here LED. Okay, then we choose what color we want, either blue, green, orange, red. Here I choose red. Okay, and for ground also, we just type here ground. Okay, so next we press OK and we connect with a jumper wire. So for this task, we must start the lab. We must start our circuit at 0 volt. For the resistor, I use 50 ohm. To set the value 50, we just double click the resistor. Then we set at resistance value. We just type here 50. Then we press OK. Okay, so the connection for this circuit is positive DC power connect to resistor. The resistor will connect to LED and the LED will connect to ground, and the negative DC power will connect to ground. Okay, then we start the simulation. So for the 0 volt, the LED will not on. If I increase to 1 volt, the LED also not on. I change to the 2 volt. The LED also, we must stop our simulation first. Then we can change the DC power voltage. So we try run simulation back. Okay, the LED is still not on. I change to 3 volt. The LED is start. The LED is on. So that means the LED, to on the LED, minimum voltage must supply in this circuit is 3 volt. For the task 2, try to verify function generator output using oscilloscope. Use 5 volt peak to peak. Okay, so here we will use function generator as the input, oscilloscope as the output. So we must set 5 volt peak to add function gen. Okay. So we must open the multi-sim. So this is function gen. We just find here on the left side function gen. Oscilloscope also find here. I use 4-channel oscilloscope. Okay, so for the connection, function generator, positive function generator will connect to the positive oscilloscope. The blue color wire jumper is positive connection. COM function generator will connect to negative oscilloscope. Add the function generator as the requirement question. It states must set 5 volt peak to peak. So to get the V peak, we must divide by 2. So 5 divided by 2 will get 2.5 V peak for amplitude at function generator. Okay. So I will run the simulation. Okay, here our oscilloscope output. Okay. At the oscilloscope to easy monitor this waveform, we just click the single. If we click none, the waveform will continuous moving. So we click single to easy to monitor. The channel A, now we use channel A. We must set DC because we use DC. Then at function gen also we can change the waveform. If we want use to the sinus waveform, we just click the first waveform. So this is a sinus waveform. If we want use triangle waveform, we just click triangle. Then we run the simulation. So we can see that the waveform is now in triangle waveform. If we want to use square waveform, we just click here. Then we run the simulation. Okay, now the waveform is square waveform. So for the last task in the part 1, set the function generator to generate 1 Hz signal and use the LED to monitor the output of the function generator. Change the waveform shape and see if you can notice any difference. Okay. So here the input we use function generator and we must set 1 Hz for frequency and LED as the output. Okay, so to get the function generator, we just find here at the left side. To find the LED and ground, we can click place source. We change the group to all group. We search LED. Okay, for this circle I choose LED red. For the ground, I just type ground. Okay, then I click OK. So the positive connection from function generator will connect to LED, positive LED. For the COM, we connect to add negative LED, which is cathode, and connect to ground also. So at the function generator, the frequency I use 1 Hz because it's stated in the question. So when I run the simulation, we will see the LED will blink. Okay. Now I'm use a waveform, sinus waveform. Okay. For triangular waveform, the blinking LED is different from the sinus waveform. For the square waveform, we can see the blinking very fast. For the sinus waveform, we can see the blinking is stable, is same time for on and off. For triangular waveform, the off LED time for the off LED is long than on LED. For the square waveform, it's same. Okay, so we can see that when we use the different waveform, the LED also will blinking with different period. Okay.